Families of Functions, a free online modular course with over 200 instructional videos, 13 parent functions, and 6 transformations. Graphing technology is not required, and please make note of this quick link to the website and press pause as needed anytime during this video. We suggest that you download this PDF that explains the website and the videos. There are over 200 videos and over 340 equations graphed and illustrated. Again, this is the website. First, as a must, you should download the quick reference guide to all videos and materials for the course, and use this to decide what is included, which videos to assign. You can even copy and paste the links into your assignments. The purpose of this is to teach students online how to graph the parent functions and their transformations at each student's individual pace, or use this as a review as needed. It's modular. You only use the videos, topics, equations as needed. The student and or the teacher get to choose this. PQR, pause as needed, quit when needed, rewind if needed. Remind students to do this. Color is creatively used as a teaching and learning tool. And videos work with or without any graphing technologies. Also, this is not a quick fix. The concepts are developed as they would be in a classroom. Students are asked to observe and discover patterns, generalize, and then apply to graph specific equations. So here's a list of the parent functions. And hopefully those include all of the ones that you would hope we would use. I will point out that the linear ones and the trig functions will be coming soon. And also these are the transformations, and each one has an instructional video to explain that transformation in general. So we have vertical shifts, horizontal shifts, vertical dilations, horizontal stretch and shrinks, opposite of a function, and f at the opposite of x, talking about odd, even, or neither functions. Here's an example family, y equals x squared, contains the following videos. And so each of the 13 families is similar to this one. So 0, 1 stands for y equals x squared. P is how to graph the parent function. This would be as if you've never done it before. Goes in it in quite depth, okay? 0, 1, Q is a quick review of how to graph that. So you may just say, oh, I did it before, but I'm not really sure I need a review. That's what the one you would use. Then we have 2 vertical transformations, 2 examples of vertical transformations. You'll notice there's 2 equations listed. The first one listed is the illustrated example, and at the end of one is a self-assessment called Now You Try One. So this would be the illustrated one, and this would be the Now You Try One. And then the horizontal, there are 2 sets of those. The dilations, the horizontal stretch and shrinks, the opposite of function, and the f at the opposite of x. And then we have 3 examples where they're all combined, A, B, and C, C for combination. This is a lower level, this is a moderate level, and this is a more difficult level. At any time to return to the main menu, click this logo at the top of each page. I do want to show the actual PDF, and to get that actual PDF, here's another quick link to that. You may want to pause the video and copy that down. That is an underscore. These are all lowercase. And this is what that PDF looks like. You can see it's just what I showed you before, but all is one page. We would suggest you download this and print it, or at least download it and have access to it. And again, here is the link to get to that. The development of these videos has taken close to 500 hours, so we really hope these are very helpful and used. So let's go to the TI Families of Functions landing page. Again, this is the link to that, bit.ly/lowercase f, letter O, F, capital TI. And this is the landing page. So here we are at this landing page. This is live right here. I'm not going to discuss everything, just point out the highlights. Again, the main thing is to download this quick reference guide, or at least look at it. Okay, download it and have access to it. I'll show that a little bit later. For each one of them, it's capital P is how to graph a particular parent function. Capital Q with a clock, with a quick way to do it. The different transformations each have a single letter to identify them, which you do not have to memorize. And then there are 13 modules, and these are the 13 that I mentioned before: quadratic, absolute value, square root, and so on, including going to a generic piecewise function as well. All right, so let's go ahead and look at module 2, the absolute value function. So I'll click on this box right here. And when you go there, all of the families of functions look like this. There'll be the module number and the name of the function, in this case y equals absolute value of x. There'll be two ways to get to the parent function. You either can click here or click this equal sign here, and that will show you the video to the parent function. Let me just do that. I'm not going to play the whole thing, but just want you to see what that would look like. And so it pops this: how to graph y equals the absolute value of x. This is Tom Reardon. So this kind of gives you an idea what that would look like. Okay, and notice the length of this is longer because this is the one that does explain the parent function for the first time. Also, you'll notice you can download graph paper if your students need to do these, because these are meant to be done by hand, how to graph by hand. If I wanted to look at the quick reminder video, I would click on this link right here, and it would play this. Notice this is a little over a minute long. Quick. Review how to graph y equals the absolute value of x by hand quickly. Okay, and you can see, just kind of run through that video and see how that absolute value v, and you'll notice that continuing on the absolute value page, you'll notice then there's a blue box of videos. These are the transformation videos, how to do a specific transformation. So for example, vertical shift, horizontal shift, and so on. These are the longest videos here, and they are taught as if they were taught in a regular classroom. When we field tested these with students, they kept saying the videos needed to be short, and we agreed. But when we asked them what would we take out of these, there was nothing we could take out, because this is taught for them to discover the learning, not just say, here's how you do it. Once they've done, let's say well, let me just click on this to show you what that looks like. Okay, so this is the exploring vertical
Investigate the graph of y equals some function plus some constant v by hand using a table with technology, and then
and you can see that this one is,
you will need graph
a little over 16 minutes long. Okay, and once you've done that, okay, then you can go and do specific ones, like here's a specific example: y equals absolute value of x plus a constant. So you click on that one and it will take you there. And we do this two different ways.
Graph y equals the absolute value of x plus 2 by hand and 2.
Okay. Notice we have f of x minus a, and then we have the horizontals, the dilations, and then this arrow takes you through the rest of them. Okay. And the last ones are the combinations: simple, moderate, and complex. And they all pretty much work that way. To return to the main menu, I'll go back up to the top of the page and click anywhere along here. Click on there and it will take you back to the main landing page. This time I'm going to go down to y equals 1 over x and click on that module and just show you again how similar that looks to what we saw before. The only difference is this is the only one that has a part 1 and a part 2 of the parent function, because it took a lot longer to describe that for the first time to our students, so that's why it has two parts to it. But notice again the transformation videos in general, and then the specific ones to y equals 1 over x. So again, we'll go back to the landing page, and as I mentioned before, the main thing as far as I'm concerned is downloading the quick reference guide. So when I click on this, it will open up a PDF, which is basically a table of contents showing the 13 parent functions. And then at the bottom of that are the video links to the transformations. Now you'll notice there's 2 links to each one. They take you to the same place. These are the YouTube links, which are kind of nasty. I did create bit.ly links that all start off with the same letters, bit.ly/TI21, lowercase FOF, and then I use the code at the end. So if I'm talking about the vertical transformation, would be V or H or D or K or whatever it may be. And I did that so you could assign them more easily, or you could just copy and paste the links. So here are the parent ones for the squaring function, and then for the absolute value function, and so on. So let's just go ahead and look at the parent function. Well, now before we do this, what I want to show you the rest of this is just a couple of the videos quickly fast forwarded. So hang in there, I just got a few more minutes. So here I'm just going to show you the slides that I used to create the videos, talking real fast. Remember, I would go slower and the students have the chance to pause. So this is how to graph y equals x squared. And so we always say you can get grid paper if you need to, because you need to do these by hand. And so we start off with a grid, start off with a table, and we need these 7 values for x. And then I'll ask them to substitute into y equals x squared. You get 3, 9. They're asked to complete the table, pause as needed, resume when they're ready. And so you should get these ordered pairs. And again, I'll remind them, in case you didn't do that, do it again. And then I give those the values. And we're going to go ahead and plot them, 3, 9, 2, 4, and so on, so they can see that. And again, I would go slower in the video. Now I do want them to notice patterns here in the table and in the graph. So I'm hopefully that they'll see symmetry here, same different x coordinates, opposite x coordinates, I should say, same y coordinates, and using color to be able to illustrate that as well. So this is called symmetry. So this is symmetric about the y-axis, or the line x equals 0. Also, at the first time around, I want them to think, is this a V shape? And so to do that, I'm going to put in 2 other values for x, 1/2 and -1/2. 1/2 times 1/2 is 1/4, to the surprise of some of our students. And then also -1/2, the quantity squared, is +1/4. So let's go ahead and plot those 2 points. And is it a V shape? And the answer is no, it is more of a U shape. And so we'll connect the points. And we talk about terminology like this is the vertex at the origin. This is the mirror line, or what we call the axis of symmetry. I like to see that with color just to kind of show that. And then where you talk about dances for how to graph these, so the parabola dance for this is to start at the origin and then go right 1 up 1, because 1 squared is 1, right 2 up 4, 2 squared is 4, and right 3 up 9, 3 squared is 9. And then similarly on the other side, connect the points, and that's how quickly you can graph a parabola using what we call the parabola dance. Also notice the symmetry about the y-axis. Domain and range is something else we want to talk about, and we talk about how the domain is all real numbers and how the range is the 0 and the numbers greater than 0. We also point out where can you see parabolas in the real world, and this is taken at the World War II Memorial in Washington, D.C. Let's compare that to a quick review how to graph y equals the square root of x. You've done it. We're just going to review it by hand quickly. So we're going to use what we call the radical dance. And we start off with the initial point, which is at the origin, because the square root of 0 is 0. From that point, we go right 1 up 1, the square root of 1 is 1. Right 4 up 2, the square root of 4 is 2. Right 9 up 3, square root of 9 is 3. We could also have done right 16 up 4, but ran out of space. We connect the points, and we can see that that's y equals the square root of x. I could also try to show you how we investigate the graph of y equals f at the quantity x minus h, and so on. I'm going to let that go for now. And then also show how you would quickly graph something like y equals the absolute value of the quantity x plus 4. Okay, we do the absolute value dance, but we go start to the left 4 units, and because of the plus 4, and then we go ahead and do our absolute value dance. Right, 1 up 1, the absolute value of 1 is 1, and so on. Again, that's much quicker than we normally would do. We also do this by comparing it to the parent function, everything shifted left 4. We also do it by table, and I'll leave that for you to get that. If you do use these, we would appreciate feedback, positive or negative. This is my email right here. If you'd like to help evaluate the next batch, which are linear functions, linear equations, we are taking volunteers. Commitment is about 15 minutes per week or so. We hope this was worth your time, and these are the two shortcuts to the websites.